How AI agents function. AI agents operate in a dynamic environment, interacting with data, systems, and sometimes humans to accomplish specific tasks. Their functioning relies on a combination of perception, decision making, and action, which allows them to autonomously adapt to changing circumstances and environments. By leveraging advanced algorithms and learning techniques, AI agents are designed to make intelligent decisions, often simulating human reasoning and behavior. The role of perception, decision making, and action. At the core of an AI agent's functionality are three key processes: perception, decision making, and action. These processes define how the agent senses its environment, evaluates what is perceived, and takes appropriate action. 1. Perception. AI agents rely on various sensors or data inputs to perceive their environment. This input can come from external sources, such as cameras, microphones, or APIs that provide real-time data. For example, a self-driving car uses cameras and LiDAR to perceive its surroundings, while a customer service AI agent might gather input through text or voice commands. The perception phase is crucial because it forms the basis for everything the agent does afterward, enabling it to understand the situation or problem it needs to address. 2. Decision-making. After gathering input, the agent moves to the decision-making phase, where it processes the perceived data. This step involves interpreting the data and using predefined rules or learning-based models to choose the best course of action. AI agents often leverage decision-making algorithms such as decision trees, neural networks, or reinforcement learning techniques to evaluate different options and make intelligent decisions. For instance, a financial trading agent analyzes stock market data, assesses risks, and decides whether to buy or sell assets. 3. Action. Once a decision has been made, the agent executes an action in response to its environment. The action taken depends on the task the agent is programmed to perform. This could involve sending a command to another system, moving an object in a physical space, or producing a response to a user query. For example, a robot agent might move an object from one place to another based on its decision-making process, while a conversational AI agent would generate a response to a question asked by a user. Understanding autonomy in AI agents. A defining feature of AI agents is their autonomy, the ability to operate without human intervention. Autonomous agents can make decisions independently based on the data they perceive and their pre-programmed goals. This autonomy is what distinguishes AI agents from traditional software systems, as they do not require continuous manual input to function. Autonomy in AI agents can range from partial autonomy, where agents perform predefined tasks based on certain conditions, to full autonomy, where the agents not only perform tasks but also adjust their strategies and objectives based on real-time feedback from the environment. For example, an autonomous drone can fly along a pre-planned path while avoiding obstacles in real time, making decisions about its route without needing direct control from a human. Autonomous systems are particularly useful in complex environments that are too challenging or time-consuming for humans to manage. Autonomous vehicles, industrial robots, and virtual assistants are just a few examples of where this independence is crucial. However, designing fully autonomous systems presents challenges, including ensuring that the agent makes ethical decisions, adheres to safety standards, and can handle unexpected situations. Learning mechanisms in AI agents. Learning is a fundamental aspect of many advanced AI agents, allowing them to improve their performance over time. The most common learning mechanisms in AI agents are supervised learning, unsupervised learning, and reinforcement learning. 1. In supervised learning, AI agents are trained on labeled data, meaning they are given inputs along with the correct outputs. The agent learns to map inputs to outputs and improve its accuracy over time. For example, a customer service agent might be trained using historical chat logs, learning to identify common customer issues and the most appropriate responses. 2. Unsupervised learning. Unsupervised learning involves training an AI agent without labeled data. The agent is tasked with finding patterns, anomalies, or groupings within the data. This learning method is often used in clustering and anomaly detection tasks. For instance, an AI agent might analyze consumer behavior and group customers into segments based on purchasing habits. 3. Reinforcement learning. In reinforcement learning, the AI agent learns through a system of rewards and penalties. It interacts with an environment, takes actions, and receives feedback, positive or negative, based on the outcomes of its actions. Over time, the agent learns to maximize rewards by making better decisions. A classic example of this is a robot learning to navigate a maze, where it receives positive rewards for moving closer to the exit and penalties for hitting walls. Learning mechanisms allow AI agents to adapt to new data and environments without being explicitly programmed for every scenario. This adaptability makes AI agents more efficient and effective at performing tasks in dynamic or unpredictable settings. As AI agents continue to advance, their learning abilities will become increasingly sophisticated, enabling them to tackle more complex challenges with minimal human oversight.